So this track is sponsored by Enphase, and we're very excited to have Paul Nahi, the CEO and president of Enphase Energy, just give a few comments and introduce today's afternoon topic for us. So Paul?
Great. Thank you. So welcome. Great to see all of you. Great to be here. So there's going to be a lot of great discussions, a lot of great topics discussed this afternoon. But I think it's very important that as we have these discussions, as we look at inverters and balance of systems, that it's all done in the proper perspective. You know, last year we had what? Maybe 100,000 solar roofs in the US, residential roofs put on in the US. This year, I don't know, maybe between 150 and 200,000. If we're thinking about 100,000, 200,000, 500,000, we are doing ourselves a tremendous disservice. Those numbers are completely irrelevant. Those are not the numbers we should be focused on. What we should be looking at is millions of roofs, both installed per year and the installed base. How do you manage 20 million roofs? Not a few hundred thousand. How do you install north of 1 million roofs a year? Not 100,000. In looking at the problem from that perspective, I think you come up with very different answers. And if we're not looking at it from that perspective, I think we're doing ourselves a disservice. So first and foremost, if you're going to get to that kind of scale, the installation process needs to be very simple. We have to eliminate this concept of special certification, special training. What we want is any skilled journeyman, electrician, roofer, general contractor to be able to install solar quickly, efficiently, and reliably. Reliably is a key. While the systems that are in place right now are certainly reliable, we need to get to a whole new level of reliability as the industry scales up. Remember, a relatively modest problem at a few 100,000 roofs becomes a very big issue when you're dealing with millions of roofs. And the way to look at reliability, I think, is in twofold. One is to focus on product reliability, to focus on making sure that every unit is tested and being built to just a new evolution of standard, to something that more akin to what happens in the automotive industry, in the medical industry. Those are the standards that we should aspire to. In addition, we need to look at system-level reliability. It's not just about the unit, it's the entire system. So what do I mean by that? Right now, when a system goes down, it's an emergency. And it's an emergency for both the owner of the system as well as the installer. We need to develop an architecture that eliminates that sense of urgency, that as the system is built, that the system itself is more resilient, more robust, and can support an occasional issue without it being a catastrophic event for either the homeowner or the installer. What that requires now is an operations and maintenance infrastructure that can support managing these systems, because it is a physical device. And as hard as we try to get to zero failures, we'll never get to zero. We're going to approach it asymptotically, but we'll never get there. There will be issues. There are issues with every appliance. But there is an O&M infrastructure that deals with your appliances. When a repairman comes out to fix your refrigerator, he's not upset. That's his job. He's making a living off of that. The O&M infrastructure that we need to create and build for the solar industry is one that, again, does not create a catastrophic event for the owner where they're losing money, does not require a developer, an installer, somebody who's responsible for O&M of a system to have to drop what they're doing to go fix that. We have to develop systems that, first of all, allow for the remote monitoring of the system. Without these systems being networked together and being managed through a cloud-based data center, it will never scale. There's no way you're going to touch millions of roofs a year. Not possible. So let's just acknowledge that. And let's recognize that part of the infrastructure that needs to be put in is an automated, cloud-based O&M infrastructure that takes the manual labor out of it and turns that into an algorithmic problem. That scales extremely well. So now we have an O&M infrastructure that can scale and not only can tell you that there may be an issue, but with a degree of granularity such that when the installer goes out there, he's got the tools, the equipment, the product he needs to be in and out as quickly as possible. So now O&M is becoming yet again more efficient. So now we have a situation where we're talking about maintaining that system to be up and functional and productive as long as possible. The reason that's important is not just an O&M reason, but what is the reason today that solar is where it is today? It's very simple. It's economics. Today, solar energy for many consumers is a cheaper form of energy than their utility energy. And the dynamics behind that are improving. Fossil fuel, carbon-based energy is going up in price. Solar energy continues to come down in price. Now, that does not mean that there won't be roadblocks, there won't be headaches, there won't be issues. When you disrupt an industry as large and as long-lived as the utility industry, you are going to ruffle some feathers. But they're not going to stop solar. Any kind of pretense in that direction is short-lived. There are already utilities that are embracing solar as part of their energy mix, and we're going to see more and more of that. So as a result, what we're talking about is providing a product that provides an economic benefit for the consumer, and you do that by maximizing the amount of energy that's being produced by that system at any given time. So that's a product decision, that's an architecture decision that says I'm going to build that system such that it will always produce the maximum amount of energy, and then you make sure it's up for as long as possible. An architecture that does not allow for a catastrophic failure. An architecture that does not require a specially trained or specially certified individual to come out to address a particular issue ensures that you have a higher uptime. And I would say the last point, and I think we can all agree the most important point, is that the industry maintain its sterling reputation for safety. Right now, solar is perceived as a safe and stable product that sits on a roof. But as we were just talking about, a small issue in the hundreds of thousands of roofs can become a very, very big issue when you're talking about millions or tens of millions of roofs. So the system itself has to be safe by design. Now that means using the appropriate building processes, techniques. It means making sure that technologies such as arc fault protection are in place, and better yet, eliminating the high voltage that's running through the house and sticking with the voltage that's running in a building, commercial, residential building. But by employing these techniques, by building that infrastructure now, we're allowing ourselves to grow to millions and tens of millions of roofs. Anything we do today that does not envision the millions and tens of millions as the goal is taking us down a path that we're going to regret. We can build that infrastructure today. We know that the market can support it. Now it's up to us to make sure that we build the foundational and the corporate infrastructure to make that happen. So with that, I'll turn it back over to MJ.
All right, thank you, Paul. So once again, my name is MJ Shiao. I'm the Director of Solar Research for GTM Research, and I lead GTM Research's Inverter and Balance of Systems practice. And today I want to talk about the PV cost reduction roadmap when solar becomes a mainstream energy source. And basically, a lot of that's going to be talking about how do you deal with the BOS, the BOS part of the system. And I'm glad that Paul was able to touch on a lot of topics that we'll continue to cover through this afternoon, and of course, a conversation that's continuing on beyond these couple of days that we have together. For those of you that, all of you should be familiar with GTM Research by this point, so we'll just get right into it. So let's look at the global context, right? Where is the solar industry today? And if you look at global solar installations, PV installations connected to the grid, we're sitting at about 130 gigawatts, of which 70% of that was installed and connected in just the past 4 years. And if we look 4 years into the future, to the end of 2017, we'll see that number increase by 2.5 times to over 350 gigawatts of solar PV. In the US, we're seeing similar growth profiles, of course, 12 gigawatts at the end of 2013, up to over 40 gigawatts by the end of 2017. So everything's great, right? The solar industries continue to grow. There's lots of opportunities. Why are we discussing the tough topics, right? Well, I want to take some pictures of the Grand Canyon. And this is kind of the perspective that I think a lot of us in the room have, right? We're looking across the Grand Canyon. We see this other side where there's mainstream solar, right? We're not quite there yet, but it's in view and it's beautiful. But the way before us is a little bit cloudy. Actually, today's earlier session on where we were doing the crowdsourced market insight on the ITC was a little bit surprising. I thought most of us would have more of this view of what's about to happen, where this is 2016, and we have to find the momentum or some kind of bridge to reach solar in the mainstream, right? But my point is here that we can kind of look at it as subsidy cliff, but I think we do have the momentum to make it across. And I think a big piece of that, of course, is going to be cost reductions within solar PV. And so let's take a moment to just see the progress that we've made. In 2009, 4 years ago, when the total cumulative market was just 30% of what it is today, we see that we are installing, well, that should say $8 a watt for PV. And even more surprising is we can install a residential solar system in the US today for what it costs to buy a module, inverter, and the racking system in 2009. It's kind of amazing if you think about it. Pushing forward to 2017, of course, a lot of that previous cost reduction came from module cost reductions, module pricing reductions, and we don't have $1.50 to drive out of the PV module anymore. It would be great if we did, but we don't. But there's some key takeaways that when you look at the buildup of solar, and this is for residential solar, but it's true for commercial and utility as well. And first of all, it's that module price reductions aren't going to take us there. We are seeing prices go up this year. We do expect them to start coming back down in 2015, but it's only going to account for a few cents a watt. However, it is important that all these little incremental penny per watt here, a couple of cents per watt there, it's going to add up, and that's where we're going to find a lot of our cost reduction going forward. And finally, we have to start focusing on the big pieces of the pie again, right? And if we look at the breakup here, it's labor and, I have a love-hate relationship with the term soft costs, but also soft costs are a big piece of what we need to be targeting moving forward. What I mean by stopping, not looking just at component prices and looking more towards labor and soft costs is if we look at something like, again, let's stay in the residential space, racking, for example, traditional rail clamp-based system. If you look at the raw materials in that rail, the aluminum and the processing costs, there's just not much room to go down. I mean, we can talk about scaling up, you can talk about designing more efficient profiles, but you're not going to be able to squeeze many more pennies per watt out of that. And so what we really have to look for is moving towards, again, labor soft cost reductions. And so what I want to talk about and diving in today is 4 ways to drive down BOS costs without beating up your component supplier. And the first one is eliminating as much balance of systems as you can. If you don't need it, you don't have to pay for it. Making your system and your balance of systems more modular in design, and we'll talk about what this means in a little bit. Being more efficient with how you're using your balance of systems and your system itself. And finally, managing that balance of systems and system over the long term. And you can probably do a little bit of beat down on your component suppliers as well. So, of course, everybody knows that the best boss to have is no boss at all, right? So let's talk about how we can start eliminating our BOS. And one way that has come up a lot is elongating strings. So by moving from lower voltage designs to higher voltage designs are using power electronics. So this means in commercial systems moving from 600 volt DC to 1000 volt DC, from 1000 volt to 1500, or you can use DC optimizers to kind of mimic that experience as well. And so you have this massive utility project at 18 kilowatts at 600 volts, and that's 60 modules, 300 watt modules, and you have basically strings of 12, so you have 5 strings of 12. And this is what your stringing diagram looks like. It's been a few years since I've had to do one of these, so apologies if it's a little bit messy. But if you move to 1000 volts here, suddenly that same 18 kilowatt array, you can get 20 module strings, right? And so now you have 3 strings instead of 5 strings. You reduce the amount of combiners you need. You reduce the amount of home run wires you need on the DC side. And even more importantly, it's not just the materials itself. It's really about the labor and the cost to install those. Looking on the other side of things, and not just the electrical balance of system, but the structural balance of systems. What can we do to again, eliminate balance of systems, eliminate labor costs? And a big push right now in the racking industry is really to simplify the structure itself, right? To stop doing cutting and welding and all this customization out in the field and move that labor from the field to the factory. You know, doing things like even as simple as pre-kitting, you know, instead of sending your installer a box of bolts and clamps, you know, actually making sure that they match what they're installing and saving time out in the field. And essentially what you're trying to do here is, again, change $40 an hour field labor into $14 an hour factory labor, right, and gain reductions there. Another thing that has gotten onto a lot of people's radars, especially after Zep Solar got acquired by SolarCity, is going railless, for example. And yes, there's a trade-off here. You're slightly less universal, you have more mounting points, but you eliminate an entire piece of the balance of systems puzzle. And so this is kind of data that it's a combination of data from the Rocky Mountain Institute and our own data. And if we look at just the labor savings involved with not having to deal with a rail, you can save around 2 or 3 cents a watt. And that might not sound a lot, but let's think about what 2 or 3 cents a watt means for a 5 kilowatt system, right? That could mean 5 to 6 man hours out in the field in terms of installation. And that can be the difference between a 1-day installation and a 2-day installation. And now you have to think about what's the overhead? What are the setup and breakdown costs and the travel costs associated with a longer installation time? And so these are topics that we're starting to look at as well. What does operational efficiency look like? What does the speed of solar installation need to look like? And we'll talk a little bit about this in making our systems more modular. So right now we're in this shift in the industry where we have this central design philosophy, and this is not just inverters and microinverters or DC optimizers, this is everything, where we're looking at just optimizing the system versus a little bit more modular design that's more focused on speed, scalability, and flexibility. And I like to think of this a little bit like the evolution of dating in the US. And stick with me here for a little bit. But when I think about when I first was courting my fiance, I wanted to optimize every single date experience, right? I wanted to make everything perfect. I wanted to make sure that everything was going smoothly and going perfectly for her, right? And it turned out and it worked out well. It worked out great. But now I talk to all the the younger analysts in our office, and they're using like OkCupid and Tinder and Grouper and all these apps that are just all about a numbers game, right? It's you have a basic profile, you have something set, and you just send out as many responses to RFQs as you can find. And that is a little bit of where we're heading, right? You have a lot of bids that are out there, and you don't have the time anymore to just optimize everything to a specific site. And so you have to be a lot better at doing cost estimation on the fly. You have to be a lot better at doing installation on the fly if we really want to see this industry go from hundreds of thousands of roofs to millions of roofs. So one way we do this, on the inverter side, you see this big shift in commercial from using central inverters to three-phase string inverters. And this is a combination of studies. Keep in mind that some of these studies are by companies that are pushing three-phase string inverters, right? But they're all about the same, and I'm not sure why these numbers aren't showing up here, but they're all about in the same ballpark, around 3 to 5 cents a watt in terms of savings by moving your electric BOS from AC or from DC BOS to AC BOS by going with the three-phase string inverter and some of the labor savings that you can also get from eliminating your combiners and things like that. That's really exciting, but again, there's an operational efficiency benefit to it as well. And so I think about it back when I was a commercial project engineer, and I'd have a BD guy or sales guy come into the office and say, I've got this great roof, right? It's perfectly clear of everything. Let's slap as much solar on there, and it's going to be a great project for all of us. And I'm sitting there designing a couple hundred kilowatts, which was huge at the time. And then you get the roof guy, you get the facilities manager to take a picture of everything, and you notice that they've just built some ridiculous new rooftop equipment on there. And now I have to take 50 kilowatts off of my design. And now I have to figure out, OK, I'm in between 2 different central inverters. Like, which one should I use? Should I do? So there's a lot of changes that happen throughout the design process and through the installation process. And when you go with a more modular design, what you're doing is you have these benefits that are a little bit difficult to quantify, but more, again, on the operational OpEx side of the equation. So being able to do faster, more accurate cost estimates. If you have a 30 kW subarray that all the parts and pieces that go into it, and you just need to replicate that 10 times to turn it into a 300 kW array, it's going to be easier than moving from 270 kilowatts to 300 kilowatts and figuring out how you're going to restring everything on a central, with a central design. There's a little bit more resiliency in the unexpected. One of the things that some installers tell us is that the reason why they've gone with microinverters is because when they get to a residential rooftop and someone didn't point out a vent stack, they just need to move a module around instead of, again, having to completely restring, redesign the system when they get to that job site. And finally, less dependence on individual components. I try not to call myself a pessimist, but sometimes I worry a lot. And I worry a lot about the operations and maintenance. And as solar, again, goes from 130 gigawatts to over 350 gigawatts, what does that mean on the operations and maintenance side? And how do we take care of systems over the long term? And so we need to look at having less dependence on single critical failures, and try to have, again, more resilience within our systems as well. So the third thing I want to talk about is being more efficient with your balance of systems. And when we talk about efficiency, everybody naturally jumps into module efficiency, right? What is the value there? And of course, if we look at what the benefit of in the next 4 years of going from what the standard multi-crystalline solar module to something a little bit more efficient, and you gain 2%, we see around 6 to 10 cents a watt balance of system savings within that. But what I really think is more exciting is being more efficient in how you're using your hardware. So one of the things that we look at is something that's very popular in Germany right now, like east-west-based systems. So instead of having a single south-facing array, you kind of have this combination of an east-facing array and a west-facing array with some shared infrastructure. And what the focus here is you're maximizing the kilowatt-hour output of that area rather than having the most efficient system. And what you can look at it as having maximum savings or being able to have an absolute maximum of revenue rather than just the lowest levelized cost of energy. So, and a lot of people talk about how since there's no south-facing, the peaks are a little bit flatter. So you have a lot of people that are designing with really high DC to AC ratios right now with systems to kind of cut off that peak and make a little bit more smoother generation profile. Well, this does that as well. And what this means is when you're using this hardware more efficiently is that you're reducing things like structural costs because you're doing 2 times the amount of power, but not necessarily 2 times the amount of structure. And then you're looking at things like a small inverter for that same DC to AC ratio that you're looking at. So if module prices are going to reverse and come down, these are things that start to make sense, especially when solar becomes more competitive with retail and wholesale electricity. I want to just go quickly through, we'll talk a lot about managing your systems over the long term with our O&M reliability and our assessing inverter and reliability panel that we have coming up. But this is an interesting study that was done by Medio Control, and they found that systems without operations and maintenance actually performed about 4.4% less than PV systems with professional operations and maintenance. And if you're talking about a 12 to 15 cents kilowatt hour PPA or savings, what have you, that's about a $7 to $10 kilowatt per year value. And the question is, can we do better than that? Can we actually either improve the performance ratio even more than that, or can we lower the cost of what it takes to take care of to do O&M on a system to make that worthwhile for people to spend as well? But I also want to talk about capturing other revenue streams. This is a little bit, we're not going to talk about this necessarily happening in 2014 or 2015, but looking down into the future of solar, we focus so heavily on what is the dollar per kilowatt hour, but is there other value that we can bring with the system? And things like as simple as, all right, if you have a shaded carport system, is there some sort of implicit value you can capture by having shaded parking space versus versus unshaded parking space? And then, of course, the bigger topic here is that people care about usually is storage. And can that be an additional enabler for revenues? And looking at some of the drivers there, of course, if you look at PV, you get what PV brings to the table is the generation revenues, obviously, the tax credits. But storage also has some revenues that it can bring to the table. And together, the combination of two can be bigger than each part individually, especially when you start looking at shared electrical assets, the fact that you might be able to use some of the PV tax credits on storage, and things like that. Or even having the storage enabling the PV to begin with by sort of hiding the amount of PV that is actually being interconnected to the grid. So these are some things that we talk about and we think about at GTM Research. And the question, I want to bring it back to sort of the image that I had at the beginning, which is we have this, at least in the US, this sort of deadline at the end of 2016 as it exists. And the question is, can we bridge that gap? Can we get to mainstream solar energy before we lose the ITC, right? And one thing to point out is we've kind of done this already. I mean, if you look at the fourth quarter of 2013 in California, for residential systems, 65% of that capacity was installed without California Solar Initiative rebates. So we've already divorced ourselves in part from state-level incentives. And now, looking forward, the question is, can we divorce ourselves from the ITC? And if you just look at our cost reduction roadmaps, we're seeing about a 20 to 30% cost reduction, 20 to 30% cost reduction from now until 2017. And so if you think of the ITC dropping from 30% to 10% as basically just the system getting more expensive by 20% overnight, right? You can see that we basically go back to costs around the 2014 or 2015 level. And we can make systems work right now, right? It's certainly we had this earlier topic on demand pull-in that could happen because of the expiry, and certainly that's going to have an effect on demand. But the point is that the solar industry, yeah, maybe it'll take a step back, but we're not going to disappear. And as costs continue to drop, we should still continue to see rising installations in the US going forward. So just to conclude on the analysis portion of it, we do have a bridge across this canyon, and we, as an industry, we just need to work on actually crossing over it and building it and crossing over it. So we have an exciting afternoon today. I'm really excited. Our first panel coming up is going to be assessing inverter performance and reliability. Basically, it's will my inverters break and how worried should I be? Next up, we'll have our first time doing a PV asset management topic, and that's what should I do if my inverters break and how worried should we be? You have a coffee break, so you can mull these things over. You can ask people whether their inverters are breaking and if you should be worried and what you should do if it happens. Then we pick back up at 4:15. We'll talk about BOS cost reductions and rooftop and so other stuff that might break in my PV system. And then finish off with BOS of tomorrow, so disruptive technologies, looking at new stuff at bigger and larger scales that you should be worried about too. And then we'll drink our worries away at the networking reception later tonight. So just want to conclude with thank you for being here, and we'll have an exciting session coming up. We have a few minutes left for questions and answers, so I just want to open it up if anyone has that. All right here. Sure. Paul, do you want to answer a question?
Please. Could you go into a little bit more detail on the part you mentioned about knowing about problems ahead of time? You mentioned something about algorithms. I thought that was interesting. That the installers get in and get out. That's pretty efficient. Can you just get into a little bit more detail?
Sure, sure. So just as an example, today Enphase collects somewhere in the neighborhood of 400 gigabytes of data every day. This is coming from inverters all over the world. And what it tells us is what's happening with the inverter on the AC side, so we know what's happening on the grid. It tells us what's happening on the DC side, in other words, what's happening with the module. We have, I don't know how many millions of inverters all over the place. It would be impossible today to actually address that individually. And if you're just monitoring the aggregate energy production, there could be issues. I would argue in many cases there are issues, you're just not aware of them, which are bringing down the total energy production. The only way to address this in a scalable fashion is to introduce a networking technology, which is actually a couple of technologies. There's the technology that takes the data from the inverter and sends it to your data center. We use a power line technology, but there are others. And you want to do that in a fashion that's as simple and as quick for the installer as possible. Now you're collecting all this data. And as I said, it is gigabytes and gigabytes of data. You need algorithms that can look at that data and then make a determination as to what's happening, which is far more complex than it sounds. Like, how do you know if there's an issue or just a lot of snow? How do you know if there's a shade condition or you've got a diode on the back of a module that's busted? Understanding what the signatures, the electrical signatures of voltage, amps, to be able to diagnose those problems and provide that information to the installer before he ever gets in a truck. So now when he's driving out to the site, he's driving with whatever needs to get repaired, with whatever information he needs, whatever tools he needs. He knows exactly where the problem is, so he's in and out as quickly as possible.
And you are constantly trying to improve those algorithms?
We have a whole team that does nothing but work on that kind of that data and refine the messages so that we can be more and more accurate over time as to what exactly is going on.